Hello everyone. Welcome to chemistry class with Demoya.
Welcome to science class with Demoya, where you will learn more about biology and chemistry.
Today, we will be talking about acids and base based on pH and titration. By the end of this lesson, you will be able to 1. Explain what acids and bases are and describe their key properties. 2. Describe how the pH scale is used to measure acidity or basicity of a solution. 3. Explain how titration can be used in determine the concentration of an unknown solution. What are acids? Acids can be defined as substances that donate hydrogen ions in water. Some common properties of acids is that it has a sour taste, pH less than 7, reacts with metal, and good conductor of electricity in solution. Examples of acids are hydrochloric acid, vinegar, lemon juice, also known as citric acid. You have strong acids and weak acids. An example of a strong acid is hydrochloric acid. Strong acids are fully dissociated in aqueous solution. As all acids do, they also donate their proton or hydrogen ions. Now, weak acids only partially dissociate in aqueous solution, setting up an equilibrium between the unreacted molecules and the ion produced. What are bases? Bases are substances that produce hydroxide ions in water or accept H plus ions. Common properties of bases are that it has a bitter taste, pH greater than 7, slippery feel, and neutralizes acids. Examples of bases are sodium hydroxide, which is NaOH, baking soda. Next, you will talk about the pH scale. The pH scale measures how acidic or basic a solution is. The pH scale ranges from 0 to 14. From 0 to 6, it is acidic. 7 equals neutral, and from 8 to 14 equals alkaline. An important concept to remember is that each step on the pH scale represents a 10 times change in acidity. Example, pH 3 is 10 times more acidic than pH 4. Now, let's talk about how scientists measure pH. Scientists measure pH in several different ways. Some of the most common ways is by using pH paper, universal indicator, and a digital pH probe. First, we have the pH paper. When pH paper comes into contact with a solution, it changes color. We can then compare that color to a pH scale to estimate the pH of the solution. The other method is the universal indicator. This also changes color depending on the pH of the substance, but it can give us a wider range of colors across the pH scale. We can also use the digital pH probe, which give us numerical pH reading. This is useful when we are needed to have a more precise measurement. So, on the pH scale on the right, you can see where the red and orange colors are acidic, which represents pH values lower than 7. And at 7, it is neutral, which is shown by the color green. And above 7 are purple and blue, which are basic and alkaline. Question: What do you think happens when an acid comes into contact with a base? Think about it and make a guess. Instead of simply remaining acidic or basic, they can react with each other in a process known as neutralization. So, let's look at the example on the slide. We have hydrochloric acid, HCl, reacting with sodium hydroxide, NaOH. When these two substances react, they produce sodium chloride, NaCl, which is a salt and a water. So the equation is HCl plus NaOH forms NaCl plus H2O, which is salt and water. But why is this reaction important? Neutralization reactions have several practical uses. They are used in medicine. For example, when substances are used to help neutralize excess acids. They are also important in water treatment, where chemicals can be used to adjust the pH of water. Neutralization is also useful in agriculture, where the pH of soil can be adjusted to make it more suitable for growing crops. So the main thing to remember is that neutralization is the reaction between an acid and a base, producing a salt and a water. Once we understand how acids and bases react with each other, we can use the reaction in the laboratory to determine the concentration of a solution. This is where titration becomes useful. Titration is a laboratory technique used to determine the concentration of an unknown solution. So, how does titration work? We start with a solution whose concentration is already known. This solution is slowly added to the solution with the unknown concentration. As the known solution is added, it reacts with the unknown solution. We continue adding the solution until we reach the endpoint. The endpoint is usually identified by a color change in an indicator, which tells us that enough of the known solution has been added for the reaction to reach the desired point. There are several pieces of equipment used during a titration. The burette allows us to add the solution very carefully and measure the volume used. The flask holds the solution being tested, while an indicator solution can be used to show the endpoint through a color change. A pH probe can also be used to monitor the pH during the reaction. By carefully measuring the amount of solution needed to reach the endpoint, scientists can use the result to calculate the concentration of the unknown solution. So, in simple terms, titration allows us to find out how concentrated an unknown solution is by reacting it with a solution of known concentration and carefully measuring how much is required. And finally, these are some real world applications. Now you know all about acids and bases, focusing on pH and titration. You have reached the end of this lesson. Thank you for watching.